All right, let's work on heat of vaporization and heat of fusion. This is going to be the first part of a lesson, and it's covering page 61. So we actually need to kind of start back a lesson. So if you remember from previous days, we've been working on calorimetry, and we know that the calorimetry equation is Q equals mc delta T, and that was based on Q being the quantity of energy, M being the mass of the thing undergoing the temperature change, C was the heat capacity, which is a constant, and then delta T stood for change in temperature. We subtracted the ending temperature and the starting temperature. And that shows us a quantity of energy change. But energy doesn't just change during a temperature change. We also know that there's an energy exchange during a phase change. And so we have to find out what is the energy exchange gained as those molecules make attractions and break attractions in order to change phase. But we also know that during a phase change, there is no temperature change. There can be no delta T during a phase change. So we're going to have a new equation that we use that does not involve a change in temperature, even though there is a change in energy. And so when we're looking at phase change, we know that during a phase change, energy is gained or lost, but the temperature is going to remain constant. And so we're going to just take the mass and we're going to multiply it by what we call the enthalpy of phase change, which is going to be a constant. And that's going to allow us to know how much energy was exchanged as those molecules made attractions and broke attractions. There are two types of enthalpies or energy changes that we're going to look at here, and that's vaporization and fusion. And so I just mark those as V and F. Vaporization, I hear the word vapor in. It's also known as the enthalpy of vaporization, but it's going to deal with anything having to do with vapor or gas. So boiling and condensing is when we're going to use the heat of vaporization. We're going to know to use the V because we're going to see some key terms in the problem. Terms like boil, condense, steam, or evaporate. Another key piece of information is that it happens at 100 degrees Celsius for water. And that's going to be key for where we're going to be going in our next lesson. There are two different values that we use for water, and they are constant, meaning we're always going to use them. If we have a calorie number, we're going to use 540, and if we have joules, we're going to use 2,257. Our other value that we have is HF, or heat of fusion. Think of fusion like coming together or freezing. That's going to be for any of our phase changes involving melting or freezing. Our key terms that we're going to look for in the problem are words like freeze, melt, ice, solid, or that important temperature, 0 degrees Celsius. Again, these are constants, and we have a value for calories, and we have a value for joules when we're talking about water. Now, I want us to notice that the values for vaporization are much higher than the values for fusion. We know that from a lab that we did in class. We know that it takes a lot more energy to break attractions between liquid going into gas or release energy to go from gas down to liquid than it does to just move from solid particles to rotating around each other and sliding past each other as liquid particles. Okay, so now let's put this to practice with our equation. So our new equation that we're adding to our energy exchanges is Q equals M times H. Q is still the quantity of energy. It's in mass, it's in joules or calories. M is still the mass, but I want you to note that it's no longer the mass of the temperature change substance. Now it has to be the mass of the phase change substance, and that's going to be key in where we're going in a couple of days. It's the mass of the phase change substance. It'll be measured in grams. And then H is either HF or HV. Based on the key terms that are in our problem, we'll select the correct number and the correct unit. Note that this is different from calorimetry because there's no delta T, because during a phase change there is no change in temperature. So let's practice with example problem number 1, and we can see that these are pretty simple to solve. So our question says find the energy. Let's pick joules. Find the energy in joules required to melt 50 grams of ice, that's a mass. I see ice, that's one of my key terms. I know that ice is a key term for fusion, so I'm gonna write F above that, at its melting point. So we know that it is already at that 0 degrees Celsius. Okay, so we know that since we have ice, it's one of our key terms, we're going to have Q equals MH, and it's going to be HF because we had ice, and ice is our key term for F. So I am looking for energy, so I'm looking for Q. So I just need to take M times H. So my mass of the ice that's undergoing the phase change is 50 grams. And HF, since I'm doing joules, I'm going to use 334 joules per gram from my constant value, and I'm just going to multiply those in my calculator. So I'm going to take 50 times 334, not that, 50 times 334, there we go. And I get 16700 joules of energy. And so that's the amount of energy that was required to melt 50 grams of ice since it was already at 0 degrees Celsius. We're going to do 2 more practice problems really quickly, and then the next lesson is going to deal with the second part of the notes, which does get much more complicated. Okay, so let's flip to page 60. And we're going to be looking at just the first 2 practice problems on 60. So the first equation says how many calories of heat, so I know that that's Q, are going to be required to melt 125 grams, that's mass, of ice. There's a key term for fusion at its melting point temperature. Good, so we're already at 0 degrees Celsius. So I have Q equals MHF. I'm looking for Q, so I'm going to plug in my 125 grams. My heat of fusion for ice in calories is 79.7 calories per gram. So I'm just going to multiply those 2 values. 125 times 79.7 is going to give me 9962.5 calories. And I can have 3 significant digits, so that's going to be 9960 calories as my final answer. Okay, let's do another one. So number 2 says how many calories of heat, so I'm looking for calories again, that's Q, are required to freeze, that's a key word, that's going to be HF, 222.5, that's a mass of water at 0 degrees Celsius, so that's one of my key temperatures. I'm already there. So I have Q equals MH, and it's HF again because I had my keyword freeze. I'm looking for Q, so I'm just going to plug in my mass of 222.5 grams. My calories constant for HF is 79.7 calories per gram. So I just type that into the calculator, 222.5 times 79.7. My problem has 4 significant digits, so I can keep 4. 17730 calories is required. Okay, and so we just remember whenever we have phase change, so we see a key word about melting, freezing, boiling, or condensing. Q is the quantity of energy, M is the mass of the thing undergoing the phase change, and an H is a constant. It's either going to be HF or HV. We need to know that the F is for any of our freezing key terms, the V is for any of our vaporizing key terms, and those constants will always be provided for you. All right, I hope this helped you solve heat of fusion problems.